thank you all for coming out. I have the dubious pleasure of being not only after two fantastic keynotes, but also lunch. So my duty is to try and keep you all awake as we kind of walk through a PowerSheller's guide to Terraform. So first and foremost, why? Like, why do we care about this other tool? We're here at a PowerShell conference, and there's this notion to DevOps and this concept that's there. But really, what it comes down to is like this notion, this concept of multi-cloud is so hot right now that if you look at some of the surveys that are out there, and I have a couple of them here. But when you start talking to different organizations, and you start talking to them about what they're doing, what they're consuming, and where they're consuming it, it's all over the place. Like if we go back to probably the first time I ever came to one of these PowerShell Summits, it was probably drastically different. Like these were probably single digits in terms of what kind of companies were interacting with multiple clouds, much less seeing small businesses 60%. Like that's crazy. That is a very large number to use multiple cloud and multiple cloud services. And it's even more interesting when you spread this out across the different services themselves. So, for a while, everybody thought of, cloud as AWS, but that's not really the case. Even back in 2020, and this was the results from Stack Overflow, it was, AWS had a pretty good lead, Azure, GCP were following right behind, and then we got into the Herokus and some of the others. Then we fast forward a year to 2021, results of the same exact survey, we see pretty much everything across the board double in terms of consumption. So like this is one of those cases where when you talk to folks and they're like, oh, we're not multiple cloud, we're not using multiple clouds, we're not going down that path. All of the data seems to suggest very much otherwise. So when you talk to these same companies and you talk to these same organizations about, okay, so what are your problems? What are your trials and tribulations in terms of getting to the point of using multi-cloud? Our little bar graph is a little off in terms of the skew there, but skill shortage is absolutely the number one by 57%. Then we get into some of the other areas around inconsistent workflows being 33%, and then just silos and things that DevOps principles really help to solve, following that up at around 29%. Then if we switch out and we take a little bit of a more business-focused look at this, taking a survey from Accenture, when they talk to a lot of the C-levels, the high-level individuals within amongst a bunch of those organizations, they assume there's going to be 83% shadow IT is going to increase over the next 2 years. And this also likely goes back to that whole, this is a skills shortage problem. This is an inconsistent workflow problem. And so really what we're getting to here in this session is that this is not to tell you that you need to learn Terraform. Terraform is just another tool that goes in your toolbox. PowerShell, fantastic tool. I've used it forever. I would not be where I am today in my career without PowerShell. Terraform is also taking place right next to that in terms of the way that I manage environments and the way that everybody else in their organizations manage environments. So, it's time to, take a step back from the whole, like, all I have is a nail or a hammer and everything that I see are nails, because there are multiple tools that can supply multiple different ways to getting to your end results. So with that, my name is Kyle Ruddy. As a caveat, I do work for HashiCorp. I am in their technical marketing group where I lead the focus there on Terraform itself. However, this is not a sponsored session. This is a community session. I am very big on community events. As I said, I've been to the PowerShell Summit for the last probably 5 years at this point, as well as multiple other conferences literally all over the world. Everything that I do, I share. So if you hit me up on KM Ruddy, that's blog, Twitter, GitHub, pretty much everywhere that you can find me, that's where I'm at. And for a lot of these things that I've done, I've been recognized as a Microsoft MVP in the cloud and data center area. Hopefully, right now we're in the renewal time frame, so hopefully I make it to 5 years and get my blue chip. Though outside of that, I'm also big on the VMware side of things. I've been a VMware vExpert now for 11 years. All right, so a little bit about what we're going to be talking about. First and foremost, we're going to dive into a little bit of an introduction about what Terraform is, and then how we can use all of the skills that we know about PowerShell to start consuming Terraform. And then we get into a demo. So first and foremost, introduction to Terraform. bare bones. Terraform is HashiCorp's tooling is an infrastructure as code tool that lets you define both cloud and on-premises resources in human-readable configuration files that you can version, reuse, and share. But really though, what's that actually mean? So this means that Terraform is declarative, meaning that what happens is that you create these files that declare what you want Terraform to make in your environment. It's immutable, meaning that every time that you, or basically this turns into the conversation between, pets and farm animals, or house plants and crops, where every single time that you're going to be interacting with resources in your environment, chances are there could be, a destroy and recreate in terms of that. These are not long-lived instances. It's idempotent, meaning that every single time that you run a Terraform job, it's going to create the exact same resource on the back end. Nothing's going to be changing along the way. It is also opinionated, which can also get it into some trouble because there's a very kind of like HashiCorp way of creating and managing resources, and that's kind of the way that it follows. But if you're not into the opinionated thing, we'll get into that later. It's also open source. You can go out to the GitHub page and literally read everything that Terraform does behind the scenes, including the providers. It's reusable, repeatable. It follows the whole GitOps principles that April Edwards was talking about earlier in her keynote. And lastly, same thing, collaborative. All right, so let's talk imperative versus declarative. Now, I'm going to use an alligator because, well, I'm a Florida man, so that's what we do. We talk about gators. So on the left-hand side here, this is our imperative way of managing, say, an alligator. These are step-by-step instructions. Like literally, here's your parts and pieces. You have to have an intimate knowledge of how to build that alligator with these Legos. But then on the right-hand side, we have a different alligator. This is us just saying, hey, declarative what manner? Build me an alligator. It kind of looks different. And that's where the declarative use case kind of comes into play, because all of a sudden, once we have this alligator, we need to be like, well, except we don't want it to be in whatever this is. We would rather it be Lego. We would rather it be completely green. We would rather it not have moving parts. So you kind of build it out as you have defined it, and you let the tooling on the back end actually go through and manage it. Then we have mutable versus immutable. For those of you that are race fans, this last weekend was the Imola Grand Prix for F1, so we're going to use race cars. On the left-hand side, this is our mutable race car, meaning that everything in this race car probably is going to change over time. Whether or not be, obviously tires, rims, chassis, engine, everything is going to change over time. It's a long-lived resource. On the right-hand side, that's going to be our show car. This is going to be those, that concept of numbers matching, where, it's always going to be the same. Every time it's recreated, other than that VIN, that's going to be the only thing that changes. All right, so getting into the actual, behind the scenes of what Terraform is doing, when it comes to the way that Terraform is defined, Terraform uses these blocks. So everything is a block to define everything in within your infrastructure. So we start off with our Terraform block. This is the way that we tell the Terraform binary what it needs to do or who it needs to talk to. Then we have the provider block. The provider block just is how it talks to those external services. We have a slide specific to that here in just a second. Then we have data blocks. Data blocks are read-only resources, meaning that since most of you are probably not going to be working in a fully greenfield environment, so you're going to have to tell Terraform that it needs to know about certain things in the environment. Very similar to like a get VM. You need to know information about that VM in order to pass it to something else. Then we have our resource block that's down here at the bottom. That is going to be our resources that are actually under management. Those are the things that we are defining that allows Terraform to go out and actually create them. Then we get into what our configuration files are themselves. So here is just a very extremely basic configuration file. Up top, we have our Terraform block saying that we need to go out and talk to Azure. Then we have our Azure block or our provider block saying that that includes whatever resources that we need to either talk to Azure, such as credentials or some of the additional high-level features that we are not getting into as part of this session. And then down here at the bottom, it's just creating a very basic resource group. We can do things like give it a name. We can tell it which location or availability zone to live in. Now, we can also build on top of that. So we can separate out all of these files or all of these blocks into different files, meaning that so up top we can have our Terraform configuration in one file. We can have our providers block in a different file. We can have our resources in a different file. Or we can even break it down even further into specific resources to kind of group those together. So like we could say, hey, we want our resource group into this one specific file. As long as it's in that single directory, Terraform is going to be able to ingest it and create things based on those files. Then we get into kind of the hot button topic here that is always important to know about, at least reference, and that's state files. This is pretty much the way underneath the covers that Terraform knows and understands what is going on with an infrastructure or within that service and what it's been or what it is supposed to be versus what it is today. This is kind of a comparison thing. Now, the reason that Terraform really has a state file is because it talks to all of these different services. So, no matter if it's talking to GCP, Azure, and even vSphere, it has kind of a recollection of what's going on behind the scenes so that it can continue to check back in with that state file and make updates or plans or changes based on that. This is something that we could get into, a little more of a debate later, but that was kind of the general gist there. All right, then what do we do with this state file? Because this is, again, going to be something that's kind of important to your infrastructure. It's going to literally be kind of like a run book for your infrastructure. So you probably don't want to check that into version control. You probably want to put that into some place that's safe. So up top, we have what's known as a cloud integration. This allows Terraform to send that state file out to a service such as Terraform Cloud so that you can store it securely and open it up to different team members. However, there are also backends. So here we have an example of an Azure RM backend that uses a storage blob within Azure to store our state file. We just have to give it, resource group name, storage name, and a couple other things that go along with it, just so that we can then share that amongst team members as well. All right, let's get into the actual knowledge transfer itself. Kind of what do I know now and what do I need to know? All right, so installation. Terraform is available on basically every package manager that's out there. If you're Mac OS user, Homebrew, it's out there. HashiCorp has its own tap as well. So like the second Terraform drops an update, it's available through the tap within minutes. On Windows systems, you can use Choco install Terraform. On Linux-based systems, it's within whatever package manager you prefer. Then we get into the whole well, how do I run Terraform? Where are my verb-nouns? And Terraform has 4 different commands that you're probably going to want to get familiar with. First and foremost, the Terraform init. This is the initialization phase. This is where it reaches out and says, okay, what providers do we need to have access to? Or what services are we going to talk to? Then we have Terraform plan, which is literally a plan. Terraform says, okay, these are the steps that we need in order to get to the end result of our configuration. We have apply, which is creating and provisioning all those resources, and then destroy to tear it all down. Then we get into the extending compatibility or talking to other services. So, for those of us that have used PowerShell for a long time, it's the PowerShell gallery. When it comes to Terraform, it's the Terraform registry. So this is a place that has over 2,000 different providers, and providers are those things that allows Terraform to talk to those different services. And then it also has some other things that are known as modules, both of which we'll get to here in just a second. So then how do we connect to services? What's like a Connect Azure RM account in terms of Terraform? And this is where we get back to our provider block. So here we have the provider Azure RM. There we can set things such as subscription ID, client secret, and tenant ID. Or if that's not the way that you're doing it, it can also have integrations into your Azure CLI if you're authenticated through that means. And then yes, we do have modules. Terraform has modules as well. And basically it works in a very similar fashion to the way that PowerShell modules work because it comes down to reusable code. So this same to PowerShell modules, same to commandlets, same to functions, same to literally anything that you can share within, say, the PowerShell gallery. So what we have here is up top, we have just a very blanket basic resource group creation. And then down here at the bottom, it's the simplified way that we can call that module. So this, our example here, not that great due to the small real estate that I have as far as screen size. But when you get into creating larger applications, larger environments, things of that nature, this becomes really, really powerful, and that's part of the demo that I have later. Then functions themselves. So Terraform does have some internal capabilities to interact with both functions and expressions. So you can interact with lists. You can interact with file systems. You can test out whether something's true, false, or Boolean value. And yes, even if you wanted to, there are some regex expressions in there too. Not that I would advise that, but regex does have a place every now and then. Then we get into variable types because Terraform also makes use of the same concept of what PowerShell has within variables. It has typing, so up top we can see that we have our variable of RG name. We can give it a type. We can give it a description. We can even then build on top of that to do some added validation as well. So down here in our middle section, we have a variable called VM size. It's, again, a type of string, and then we can do some validation. So basically, we're looking for something that's somewhere between 0 or 1 and 9 characters long, and it starts with standard underscore, because we're trying to match that up to a input variable that matches that. And then down here at the bottom, another kind of key call out here, you can either call variables at the command line, you can do like a Terraform plan-var, or you can create a tf-vars file and put in Terraform or your variables into that file. Another key thing for our tf-vars file, again, highly recommend using this with source control, but this is one of those files where you're going to want to use like a .gitignore so that you don't commit that to version control, just so that you don't submit credentials or secrets or certificates, things of that nature. All right, so what else you got? So when it comes to things like write output, we can also use outputs within Terraform as well. This is really helpful, specifically when we're interacting with, say, modules, so that we can take output from one particular area and send it to another. In this case, we have what's known as an output block. Something very straightforward here. It's just value and then telling it, I want our resource of Azure RM resource group .rg, and then we want the name output from that particular resource, and that's what's going to either be returned to the screen or returned back to your configuration itself. All right, so diving into some of the actual working with Terraform itself, what about IntelliSense? That's a huge part of working and operating within the PowerShell ecosystem, and Terraform has that as well. There's actually a pretty popular extension that's available through VS Code, literally called HashiCorp Terraform. However, the key point behind that is that there's also a language server. This language server allows you to also have the same IntelliSense type look, feel, and activity within other IDEs as well. So if, say, you don't like VS Code for whatever terrible reason, you could use it with, say, Sublime, or you could use it with JetBrains, or anything along those lines as well. So very extensive in that case. Then what happens to automating Terraform? How do we, so we have our configuration, but how do we make it do something in a programmatic way? So you can either do something as simple as local executions or cron jobs, schedule tasks, any of those things absolutely work. You can start integrating it into your source control and or CI/CD pipelines. Meaning our example up here is basically using I believe this was a Circle CI example. So it pulls out a Terraform image from Docker Hub and just says, hey, by the way, Terraform apply, and then auto approve it. So every time there's a commit or a pull request that goes into your source control, boom, it's going to automatically go out, talk to your services, and execute that latest and greatest code. Then also you have other miscellaneous services that are out there like a Terraform Cloud that can have and run webhook type extensions. You can perform remote executions and even get into the case of API-driven workflows. And Terraform Cloud is not the only one that's out there. There's actually quite a few. So I've talked a lot about files and configurations and blocks, but the one thing that I haven't talked about is an interactive console. So you're probably thinking that there's no interactive console, and technically Terraform does, but it's not really the same as what you're thinking. So the Terraform console command is literally a way that you can step into a configuration file and start to interact with some of the parts and pieces that are within there. This is extremely helpful when you need to, say, I don't know, figure out what a variable actually is, if you have something that's coming up malformed, if you need to test an expression, like say our CIDRnet mask expression, or test what your output should be. So it's definitely a really cool way to kind of debug your code or test out what some features or functionalities might look like. Then we get into the more programmatic way. As I mentioned in the beginning, Terraform is opinionated by nature, but what happens if you don't like that opinionated workflow? Well, there's something that's known as the Cloud Development Kit for Terraform, or CDK-TF. This is something that we've kind of adopted from our good friends at AWS, and this allows us to turn Terraform into kind of a SDK, or really CDK, if you will. So you can use, say, C# to go through and get to those low-level programmatic ways that you're probably more familiar with, if that's your preference. There's also support for Go, Python, and TypeScript. All right, here's a really cool thing. I haven't talked to anybody here that might be from Microsoft, so hopefully I am not destroying anything for lightning rounds or things of that nature. But there is a really cool tool that's out there if you already have resources that exist in Azure but are not codified yet. This is known as Azure Terraform, which personally, putting back on my HashiCorp hat, could have had a better name, but I digress. It is still a really cool feature. Nonetheless, it allows you to run this command. So what you see here is you have the Azure Terraform kind of interactive console here. You can see that the Ruddy Azure, or AZTFY, which is the actual name that you call by the binary, and then demo, and that's my resource group. So then what happens is Azure Terraform reaches out to that resource group, says, hey, these are all the resources that we see that are out there that have been provisioned. Would you like to make these or put these into Terraform code? And it works quite well. There are a couple little nitpicks and caveats, but it works exceptionally well for the status that it's in. All right, demo time. This is where we get to see how well the Wi-Fi is working. Yes, I consider fine to be very good most days. All right, so here's what a configuration that we have. This is going to basically go out, stand up a very basic website and configuration that's going to say hi to you all. So what I'm going to do first is open up our console here. We can do a Terraform init. And that's literally going through, grabbing modules, grabbing providers, so we can see some of the things that have already been pulled in and installed previously, so I don't have to rely on the network completely. Key points here are like, say, the Azure RM provider, because I'm creating stuff in Azure. So now let's clear that out and do a Terraform apply, because we're going to skip the plan because that just takes longer. So as that's running, let's go back to our, oh wow, that was fast. All right, Wi-Fi's, or wired network is doing well. So here's kind of an output of all the things that it needs to accomplish, to plan through before it actually creates all of these things. I'll show you the code for it here in just a second, but like most importantly, like here is a Azure virtual machine, because what we're doing is standing up a Linux box and then running a script inside of it to get to our web application. And what it's going to do afterwards, the important part here is that, one, it's going to tell us our plan. It says we're going to add 10 new things, so you know exactly what it's doing before you even hit yes. And there's going to be no changes and 0 things to destroy. Then we're going to see some outputs there at the end. So let's type in yes to let that go do its magic, because that's got about 5 minutes probably. So going through our configuration file itself as that runs down there at the bottom. Starting up top, we have our Terraform block. This is going through and telling us that we're going to talk to Azure RM, and then we're going to talk to a random provider, because I'm just randomly generating certain names and things within the environment. So because I don't really care what the name is, more part of that whole like farm animal crops portion. Then you can even do things such as defining and telling it exactly what Terraform version you want it to be at. Here we have our provider block. This is where I'm going through and adding in all the parts and pieces that lets it know how I authenticate to Azure. Then here's the really cool part where we get into modules. So I have this broken down into two different modules. The top one is one that we call ARM Web App. And all it asks for is a prefix and a location. Then down here at the bottom, our next one is the web config. This is going to take the output from our web app and actually apply the configuration for our website. And these are, the important part here is that these are extremely basic in terms of repeatability, reusability. All of these things are done on the back end. So if we open up our variables file here, here's some of the things that we've gone through and kind of defined in terms of what we want to see. So we have subscription ID, client ID, authentication stuff. For our prefix, we can even put in default values. So since I did not give it any other variables, it's going to use Ruddy PowerShell Summit. It's going to deploy to the East US 2 region. And then we're getting into another kind of really crazy one where we're using validation because we're looking for an input of either products, HashiCat, or HashiDog. I did that because, well, I did one with HashiCat, and then people told me not everybody loves cats. So I did one with HashiDogs, and people told me not everybody loves dogs, and I'm just like, okay, well, we're going to do products then instead. Lastly, what we saw earlier with our outputs is we're going to ask for a couple different things, mainly resource group name, virtual machine name, and then the FQDN to reach out to that web URL. So with all that, I think we're still creating down there at the bottom. So let's take a look at our modules. So in this case, we're using local modules that live within our configuration. So we have our ARM web app that's right here. If we open this up, we can see that there's 116 lines of code that's been condensed into about 5 for when we call our module. So we have we're creating a resource group. We're creating a virtual network. We're creating a subnet. And based on that, we have a security group that not only creates that, but we also have a bunch of security rules so that we can talk to it over port 80, and I think 443, and SSH. Because SSH will be important here in a second for our web configuration, because that's doing some pretty crazy stuff that kind of sort of isn't really provisioning and infrastructure as code, it's more config management. But then we have our network interface, where we're starting to take some of our prior areas here, such as our subnet and subnet ID. We could see IntelliSense kind of kicking in and helping assign what that type of resource is. Then a public IP. Then we get into our virtual machine itself. So we're picking up some different variables that we've defined as part of this module that we've also assigned as default. And I believe that is it. All right, so we're still creating. We're at 3 minutes and 50 seconds, which should be about right to where it kicks in and actually wraps up. But we do have a backup just in case that doesn't. So let's look at our other module that's here. So with this, we're doing something really crazy to kind of pull in a bunch of different sets of information. This is where we're getting into a little bit of a more advanced topic area. So we have this notion of a local block, and the local block allows you to do a lot of things that has no outside expectations or requirements. So in this case, I'm taking all of those different variable or sets of variables and wrapping them up into one specific variable called a data set. And down here at the bottom, this is where we're calling that local data set. Again, this is kind of more of a more advanced, kind of abstract way to do it, but allows me to kind of choose in between a set of 3 different maps. And this is our random integer here that just picks out one random item from those maps. Then we have a shuffle, again, to pull out different information. Then here's where we get into, uh-oh, do I see an error? We do have an error. All right, good. I'm glad I defined, or I set up a backup earlier. So here, this is another one of those areas where we can do some crazy stuff that's not really provisioning infrastructure as code. It's more configuration management. So in this, we're using what's known as a null resource, and this allows us to SSH into our virtual machine that we created. That's this connection block that's right here. Then we are sending over a file. This is what's going to be available as part of our website there. And then we're using a remote execution provisioner. This just allows us to use that SSH connection to then run these different commands within that virtual machine. So the important parts on here is that we're doing updates, 2, we're installing Apache, and then we're using the file that we copied over for our this last string right here, which is giving it some of our information from that map. All right, so let's go back to our terminal here, see what those actually were. File provisioning error, that's fun. So let's go back to our previously run configuration here. Here we go. All right, so in the case of that demo failing, which it did spectacularly, here is what we should see as the output here. So we had a bunch of resources that were created. Note it only has 8, even though the plan was 10, because some of those are actually null resources, and therefore it's not counted within Azure itself. But then here we can see the outputs that we defined earlier. So here we have Ruddy PowerShell Summit, and this is my backup app, so it has backup in the title, so I don't overrun it, overwrite anything as far as the resource group name. If we jump out to Chrome, in this case, it's going to say Terraform says hello from our FQDN instead of an IP. So to go back to our configuration here, I'll show you what the other items that were possible were. Close that. So in case of our products variable, we had a map. So we either had the PowerShell hero, we had PowerShell itself, Terraform, and then we had DSC. And then for like the Hashy cats, we had a bunch of different cats and using place kitten on the back end for those, and the same thing for Hashi dogs and pulling those out too. All right. So we're at 1:34, so I actually do have just a bit of time to show you the other really cool thing that hopefully doesn't upset anybody doing lightning demos. So since our initial one failed, I'm going to open up our backup that I ran from before and show you what Azure Terraform ends up creating. So in terms of Azure Terraform, going back to the screen image before, it gives you a list of all the resources that are found within the resource group that you specified. And then as long as you either A, follow the guidelines for what it automatically assigned, or you update it to include particular ones, it then builds out this configuration that we see here. So we have certain things such as, we have our subnet group that's here. A couple of the things that I do want to call out when it does create this is a very static configuration, meaning that there's no variables whatsoever. So if you do want to go through and add such as a name prefix, that's something that you have to do. It also heavily depends on the depends on statement within the resource, and that just basically means that, for, in this case, the Azure RM subnet, it is going to rely on or depend on the virtual network being created first. And then the other interesting thing that it pulls out for those of you who have seen Terraform configurations before, We have the name. It auto-generates the name as well. So in this case, the resource, when we refer to it later, is Azure RM Resource Group. In this case, it shows up as Res9 as the name. You can change those in Terraform itself, or you can use the auto-generated ones, and then you can kind of refactor it later. But it does go through, it does do a couple things in a different configuration, but for the most part, it's very accurate, very well done. Here's one of the areas. So here, instead of having the security rules themselves being part of the security group, and actually built those out. It expanded those into their own different resources. So these are a little more verbose, but they're in their own resources, so it allows you a little more flexibility than what I had actually created initially through the demo. So that's pretty cool. Then we have our network interfaces and IPs. I mean, it auto-generated everything. And I've already torn down this environment because this one was actually done last night. So literally, you could take this configuration, you could open up Terraform, and if you're in that directory, you could run a Terraform plan, and it would tell you, there's nothing to do. This is accurate as per the state that it found in Azure, and therefore generated the state file, which is also here in our area here. The big thing, it did move the provider and Terraform block into its own file. And then it also includes a resource mapping for after the fact. So it has an idea of like, this is what we found, and this is what we mapped it to in terms of on the Terraform side itself. So with that, so last up, more information. Where can you find some additional info, things that you can do like walkthroughs. The HashiCorp Learn site is a great website. It's broken down into many different areas where you can focus on different aspects. So there's a Azure kind of subsection, there's an AWS subsection, there's a Kubernetes subsection, there's a vSphere subsection, and each one of these are meant and built to essentially allow you to go through and walk through it with free accounts, so you don't really have to pay for anything as you kind of go through the process of learning Terraform. The documentation, we hear very good things about the documentation. I'm fairly proud of the way that works out right now. It's literally terraform.io docs. The community is fairly large. In this case, what HashiCorp has done is they rely on the Discuss forums or the GitHub repositories themselves for a lot of the community efforts. So for that, it's kind of, in terms of like Slack groups and things of that nature, it's kind of fragmented, which is unfortunate, but it makes up for it in other places. The Terraform registry is registry.terraform.io. And then also, Azure has done a fantastic job of building out documentation to support Terraform, the Azure RM provider, and even some of the new stuff that's coming down the pipe with like Azure API, which is a new provider that talks directly to Azure's API, like as the name says. Azure AD was another one. I think there's like 6 or 7 different providers as well that Azure works with. And then, of course, the Azure Terraform GitHub repo that's there as well. So with that, that's all I've got. So I think we have like 5 minutes left if people have questions or comments or throwing tomatoes.
We didn't bring any tomatoes.
No tomatoes? No tomatoes during lunch?
No, this is Microsoft mostly, so we have apples.
Oh.
I love the name Terraform.
Yes.
Are there going to be other providers that create Terraform tools?
Yeah, so the question is about whether or not there are going to be other areas where you can automatically generate Terraform configurations like this. And there actually are several that are out there. This isn't even the first one that Azure has done. There's also one that's out there that's a little more, it covers many different providers, and it's actually created by GCP, and it's called Terraformer. So that one's kind of cool. It does AWS, GCP, Azure, vSphere. It does a couple different Kubernetes services. So it's not like all of the providers, but there's, it's a solid set of providers that a lot of folks are using.
You called out that the Terraform module or tool relies on the dependent blocks and like creates them in all your resources. But Terraform or the Terraform providers sort of implicitly understand those dependencies already, right?
Correct. Yeah. So the question is around those depends on blocks that Azure Terraform created. And those are 100% not required. That's something that Terraform actually handles extremely well underneath the covers. It already has a mapping of those dependencies that have been established and created when the provider is created. So like literally I could go through, rip all those out, and it'll still run.
Do you have a guide to not just using Terraform, but also developing new providers for it?
So the question is around developing new providers for Terraform, and yes, we do. It is out there on the registry, so registry.terraform.io, and there is I want to say it's publishing. There's a doc that's already out there. Because it kind of follows the standards, because we also, like, one of the things that the registry has is this notion of official providers, which are ones that we, or I should say HashiCorp, works on, supports, and whatnot. Then there are verified providers, which are ones that are done by partners and other folks that are within the ecosystem. And then there's community. And so there's guidelines for each one of those in terms of how they work out. Cool. Well, with that, I will let you all go. I will be around all week as well. So if you want to discuss or talk about more things, feel free to reach out and grab me.